Hello and welcome back to another video. In this problem, we're told that the half-life of bismuth-210 is 5 days. In part A, we're asked if a sample has a mass of 200 milligrams, find the amount remaining after 15 days. So a half-life of 5 days means that every 5 days, the amount of the original is going to be halved. So if we start on day 0 at 200 milligrams, on day 5, it's going to be half that, 100. Day 10, another 5 days has passed, therefore it's halved again to 50. And finally, 5 more days pass to reach day 15, it gets halved again. Therefore, if we start at 200, 15 days later, we end up with 25 milligrams. Part B, we're asked to find the amount remaining after t days. So this is an exponential function, right? The amount at a given day is dependent on the original, 200 milligrams, and the rate of change, which is halving every 5 days. So what do? We say, okay, this function, f of t, tracks the amount remaining after t days. So the structure for a exponential function is you take the original amount, 200, and you multiply it by the rate of change, right? And this rate of change is not the rate of change that you think about with a line. It is the rate that is itself changing, because it's not just multiplying by, let's say, 4, and that's a slope of 4. It's halving every single time, so it's changing. So we're multiplying by 1/2. We multiply 1/2 to the t. What this means is that every time t increases, we multiply it by 1/2 again, which isn't exactly right because it's not halving every day, it's halving every 5 days. So to make sure we halve it every 5 days, we divide this t by 5. Therefore, let's say if we're 15 days in, 15 divided by 5 is 3, we're multiplying by 1/2 3 times. Which makes sense, it's being halved 1, 2, 3 times. So this is our formula, and the amount remaining is the second half, this expression, 200 times 1/2 to the t over 5. In part C, we are asked to find the amount remaining after 3 weeks. So we have f of t, 3 weeks is 21 days, f of 21 is equal to 200 times 1/2 to the 21 over 5. And we're going to do this in conjunction with part D. Use a graph to estimate the time required for the mass to be reduced to 1 milligram. What we have here is a graph that we can pull up on a graphing calculator. And what we're going to be looking for is 2 things. We're going to be looking at the amount at 3 weeks, and the day for which it is 1 milligram. So if we pull up our function here, we can see that the exponential function here is in red, and I have 2 lines that intersect it. So this green line is the line x is equal to 21. So for all of these, this is for day 21, since the x variable, the dependent variable, is representing the days. So at the intersection point, we can see that there are 10.882 milligrams left. So that's the amount after 3 weeks. If we go down here, this is the line x equals 1. So at this point, 38, the function has been reduced enough to where there is 1 milligram left. So we can say, by looking at this graph, that this is equal to approximately 10.882, and D at 1 milligram happens on day 38.